Hi all. Next we have to study some special functions and its Laplace transform. Okay, first one is unit step function or Heaviside unit function. Unit step function is defined as u of, it is denoted by u of t minus a. U of t minus a is equal to 0 for t less than a, 1 for t greater than or equal to a. So this is the definition of unit step function. When a equal to 0, we can write u of t is equal to 0 for t less than 0, 1 for t greater than or equal to 0. And the Laplace transform of unit step function is L of u of t minus a equal to e raised to minus s by s. You have to study that. Next, second shifting theorem. If L of f of t equal to f of s, then L of f of t minus a u of t minus a equal to e raised to minus as into f of s, where f of s is the Laplace transform of f of t. So L of f of t minus a into u of t minus a equal to e raised to minus as into f of s. Consider problem. Find L of t minus 1 whole square u of t minus 1. Here this is f of t minus a form and this is u of t minus a. So from this we can write a equal to 1, u of t minus 1, therefore a equal to 1, and f of t equal to t square. This is f of t minus a, that is t minus 1 whole square, then f of t is t square. Then applying second shifting theorem, L of t minus 1 whole square u of t minus 1 is equal to e raised to minus as into L of f of t. Here a equal to 1, so this is equal to e raised to minus s into f of t is t square, so L of t square. We know that the Laplace transform of t square is 2 factorial by s cube. Therefore the answer is 2 into e raised to minus s by s cube. Next problem. Find L of e raised to minus 3t u of t minus 1. Here this is f of t minus a but not in the form, and this is u of t minus 1 to u of t minus a. Here a equal to 1. So we have to write this in the form of f of t minus a. For that, here we are adding a 1 and subtracting 1 from t. So e raised to minus 3 into t plus 1 minus 1 into u of t minus 1. Then we can separate this e raised to minus 3 into t minus 1 into e raised to minus 3. Separate the two terms and take e raised to minus 3 outside, that's a constant. Therefore e raised to minus 3 into L of e raised to minus 3 into t minus 1. Now this is of the form f of t minus a. So from this we can write f of t equal to e raised to minus 3t into u of t minus 1. That is equal to e raised to minus 3 into, here we are applying second shifting theorem, e raised to minus as into L of f of t, that is here a equal to 1, substitute here e raised to minus 3 into e raised to minus s into L of f of t is e raised to minus 3t. We know the Laplace transform of e raised to minus at, that is 1 by s minus a. So the answer is e raised to minus of 3 plus s into s plus 3. Next, find Laplace transform of sin 2t u of t minus pi. Here also this is not in the form of f of t minus a. To make that in that form, we have to add and subtract a pi. Here this is u of t minus a, so a equal to pi, so add and subtract pi from t. So L of sin 2 into t minus pi plus pi into u of t minus pi, that is L of sin 2 into t minus pi plus 2 into pi, 2 pi, and this is of the form sin 2 pi plus theta. We know that sin 2 pi plus theta is sin theta itself. So this is we can write this L of sine 2 into t minus pi into u of t minus pi. Then applying second shifting theorem, we can write e raised to minus as into L of f of t. Here f of t equal to sine 2t and a equal to pi. So e raised to minus pi s into L of sine 2t. We know that Laplace transform of sine 2t is 2 by s square plus 4. So the answer is e raised to minus pi s into 2 by s square plus 4.